Hello, everybody. You know me? Yes, excellent, awesome. There's still going to be some people trickling in, I guess, with the weather and whatnot. It always slows things down a little bit. But I'm excited to welcome you all to the April Meetup, the Austin Hardware Startup Meetup. It's actually the biggest monthly recurring meetup here at Capital Factory, which is surprising because there's a lot of startup meetups that are focused on software and web services, mobile stuff too. But we're all about hardware here, and we have an awesome speaker tonight. It's Rob from GrabCAD, and he'll tell you more about the product, but it's a tool that will actually help people building products, hardware startups specifically, especially if you have distributed teams working with mechanical and I think maybe even electrical products. So they paid for our pizza and our beer. So feel free to give Rob a hug later. Also, after he speaks, we have two local entrepreneurs. One is Justin Jensen of Synetics, who has successfully launched 3 Kickstarter campaigns. One is still ongoing, which has exceeded $500,000 so far around professional photography. So we'll be excited to see his latest product, hear how he did it. And we also have John Kessner of Super Mechanical, and this is their second Kickstarter, and they are delivering their product, and he has his final production version of it's a smart thermometer called Range. So they'll be after Rob speaks, but I'll hand it over to Rob Stevens.
Thank you. So hi, I'm Rob Stevens. You're welcome for the pizza and beer. Let me start by introducing myself and establishing what little street cred I have. So I'm a mechanical engineer by training, though I haven't practiced in almost 20 years. And I've done a series of startups, and one of them was Kiva Systems, which is it's a robot for warehouses. We automate distribution centers. So that was my last hardware startup. And now I'm in a software startup, GrabCAD, I'll tell you a little bit about. So please feel free to interrupt me at any point and ask questions. I presume a lot of people here have probably lots of experience in some of the topics I'm going to talk about, and maybe different opinions, and I'd love to hear what those are and get a discussion going. So I've introduced myself. Let me introduce GrabCAD. So who here is a member of GrabCAD? Thank you. Well, come on. Can't be just one of you. Oh, 2. Okay. 3. Oh, sorry. 3 off the top. All right. Wow, that is shockingly low. So you all need to go home and join GrabCAD, first of all, if you're a mechanical engineer. So we host the world's largest community of mechanical engineers and designers. We have 1.2, this is as of last week, so it's probably 1.22 by now, members of the community. And we also offer a set of software products I'm going to talk about. In addition, we wrote a book. So any of you who still read books, and I know it's not as many as it used to be, we recently wrote a book, or Hardy, our founder, wrote a book called The Art of Product Design, that talks about a lot of the topics I'm going to talk about this evening, and gives a lot more examples. So if you hear anything this evening that you find intriguing, you'd like to learn more about, feel free to ask me. Feel free to go to Amazon and buy the book. It's actually a good book. So anyway, that's who we are. The topic I'm going to talk about tonight is something that is probably near and dear to many people's heart. It's why is it so hard to build things? And as evidence of that, I heard Kickstarter. More than, this is still true, this stat's a year old, it's still true. Every study I see talks about 50 to 60% of Kickstarter projects fail, in some sense. Now that could be they miss by a few months, or they miss by a couple of years, or they don't use the amount. But it doesn't just affect little companies, it affects big companies. And again, this is about a year old too, but many of you probably remember the drama around the Boeing Dreamliner, the plane that just couldn't get in the air. It went on and on, one fix after another, and then when they finally got it in the air, it got grounded because of battery problems. It's hard to build things. But software engineering also faces this problem. And as I mentioned, I spent a lot of my career at software startups. And so let me just, probably some of you have as well, let me just talk a little bit about how they face some of these problems. Some things that have changed in the software world since I began my career in that space. So over the last 10 or 15 years, this is all new. So software engineers have open communities. They have tools that allow them to collaborate quickly on code. GitHub is probably the largest example. I imagine a lot of your organizations use GitHub, we do. Open source components, so Apache, MySQL, Firefox is an output of that. Linux, probably the most famous. They have online communities like Hacker News, where you can go on and post a question, get a lot of feedback, get a lot of answers. And there's this evolving idea that the agile marketing model, the agile software development model, that has really led to this idea of do it quick, test it, go through that cycle as often as you can. This is all new in the last 10 or 15 years in the software world. And if I look at those things and I ask, well, how is hardware doing on these areas? The answer is not that well. So this probably describes a lot of people's lives here. We still mainly work in a waterfall design process, right? When I started in software startups, it was code for a while, push to QA, QA for a while, push to publish it, send them out. We used to actually mail people CDs. I don't know if anybody remembers that, with software on it. Hardware largely still works this way, right? You work as an engineer for a while, then you go to a design review and people yell at you, and you go back to your desk and you design for a while. Does this sound familiar to anybody? Excellent, thank you, got a few. The tools are largely proprietary. We were just talking about SolidWorks a few minutes ago, and this gentleman said, well, I can't possibly buy SolidWorks. I don't have $10,000. He didn't say $10,000, let me put that in your mouth. I don't have $10,000 to go buy SolidWorks. So I found this other CAD tool that probably no one you know uses, and God help you if you need to share files, right? You end up sharing in these sort of dumbed down formats. So we've got the proprietary tools. The teams are very functional. The designer, the ID, the industrial designer, doesn't really like to associate with the mechanical engineer, right? We're not really the same kind of people. God forbid marketing or sales gets involved. That's my department now. The manufacturing guy thinks you're all a bunch of idiots and you're all designing things that no one could possibly make for the price you want them for. So these functional divisions remain very strong within almost every organization I've seen. And then finally, outside manufacturing, when you actually get to the point of building the thing, it's not handed off to manufacturing, throw it over the wall. It's now thrown over the Pacific, right? You don't even talk to, you're never going to meet the people making this product. So these are really blockers. And I'm here to talk about how we can do better. So we think the way to do better is to embrace the openness that the software engineering world has seen. And when I say openness, people kind of recoil. I'm not talking about everything is free and information wants to go away. I was talking about Kiva earlier. One of the reasons Kiva was so successful is we had awesome patents. If you try to make one of our robots, you're going to get sued out of existence. No one ever even tried because we had really good patents. We came up with some really cool mechanical stuff that no one can copy. So I am not a big proponent of everything is free, share your IP with everyone in the world. But we think the process of engineering can be opened up. And there's enormous leverage if you can do that. So let me just talk through what the 5 steps in the design process and give some examples each step along the way of how you can open this process up and some of the benefits you might see. So I'll start with, where do ideas come from? Concept development. Where do ideas come from? Well, in the old days, it was Thomas Edison. He went off into his, I don't know where Thomas Edison, an attic? I don't know where Thomas Edison got his ideas. And he came down with these genius inspirations. I don't know if the ideas are all getting harder, but that doesn't seem to work as well anymore. And a lot of ideas now, organizations are looking at crowdsourcing. So we do this, I'll talk about GrabCAD in a second. We're not the only people that do this. Local Motors, many of you probably heard of, they crowdsource cars. People get together, gearheads get together, and they come up with a car they always wanted, but Ford wouldn't sell to them. Crowdsourcing. DARPA's doing it. And if DARPA's doing it, you know it's a real thing, because DARPA's not exactly inventing stuff in most areas. And Quirky, I was talking to somebody else earlier about a device that came out of Quirky recently. Quirky does this idea where consumers can submit ideas. I had this cool idea for this iPhone holder, and Quirky will vet it and help you develop it, and if they make it and sell it, you'll get a cut. So again, crowdsourcing. The ideas don't come from the select few with a PhD sitting in the tower somewhere. So let me talk about how we do this. So GrabCAD, as part of our community, we call them challenges, where companies come into our community and look for ideas. And one of our favorite examples is GE. GE is not lacking for ideas. It's not a coincidence that I mentioned Thomas Edison earlier. So GE makes jet engines. But it turns out they have this bracket that goes on the jet engine. When you service a jet engine, you have to pick it up. And so there's a bracket that goes on the jet engine. They thread a cable through to pick the engine up. And no one really looked at this bracket. It's called dumb metal. Apparently in this area, you call this dumb metal. It flies, meaning the weight is incredibly important, but it's not really interesting. It's a bracket. So no one really looked at it. So GE said, hey, what if we use additive manufacturing to try to take some of the weight out of this, to remove some of the constraints? It's made out of a high-grade titanium alloy, but it was basically, like most aerospace components, it was cast and then machined. And there's real limitations to what you can do with those manufacturing processes. They said, well, we're going to try additive manufacturing. They kind of looked around, and people at GE don't know a lot about additive manufacturing. Most people don't, right? It's fairly new. So they said, let's go to the community. Let's put this challenge out, including specs and drawings and a very rigid process for how we're going to test it, and we're going to simulate it, and then we're going to test actual prototypes. So it was one of the most technical challenges we've done. So this went out to our 1-point-something million members, and we really weren't sure what was going to happen. I wouldn't be telling the story if it weren't successful, obviously. We got about 700 responses, people all over the world, with designs for these brackets. And this blew away GE. Because GE, they hadn't put a lot of effort onto this, but they kind of worked on it. So they got these responses. Then they began giving feedback. People had questions. So a big part of crowdsourcing is interacting. People aren't likely to get the thing right the first time. So if anybody here's a designer, you never get it right the first time. Software, industrial design, mechanical, doesn't matter. So there's a feedback process where they had a lot of questions for the GE team. And the result was an 80% reduction in weight for this component. And when we were talking, I was talking to the director of the innovation program there, he said, we launched multi-billion-dollar programs to take 2% off of a jet engine. So the idea that we could crowdsource this component and get an 80% weight reduction is just crazy. And the winner was actually a guy in Indonesia. And Jeff Inmelt, the CEO, this went to the board at GE, and Jeff Inmelt apparently asked, I wasn't there, he asked, well, where did this guy learn, where did he get his aviation training? And he said, he doesn't have any, doesn't know anything about aviation. But he was interested in using organic shapes and additive manufacturing, and that's what he brought to the table. GE would never have found this guy. So, great win for him. That guy was thrilled. He's now apparently the most popular designer in Indonesia, and GE is very happy. So, the idea behind this is go outside. Look outside for your organization for ideas. Crowdsourcing is one way to do it. Our challenge is not the right answer for everybody, but the idea of go outside the organization, go beyond the experts, can have a lot of power. So now you've got the idea of what you want to do. You need to flesh out that concept. And concept is where you are slapping things together to get an idea of what's going to happen. And you end up spending a lot of time here designing things that you're not going to actually make. So increasingly what's happening today, though, is you don't need to redesign things that already exist. There are places to go get them. So again, I'll give you an example from us. There's others, trace parts, which are more standard components. You can go there and find trash cans and washers and bolts and things like that. Dassault has 3D Content Central, which also works with various hardware suppliers to produce standard parts. You can drag them into your model. But let me tell you a little bit about us. We have this community that I mentioned. A big part of what attracts people to GrabCAD is that we have, I think, almost 400,000 CAD models. They're user-generated CAD models. So, for example, maybe you're building a new, the world's greatest new trash cart. And you know it's going to have casters on it, but the casters are not the magic. So you just need to go get some casters. Anybody's got a computer, if you Google 3D model casters, you're probably going to find GrabCAD. And you might go and grab it and pull it in to stand in for a part. Later on, you'll go figure out the right caster to use. For now, you just need a caster. So that's one way people use the models in a library. Another example is props. So I'm designing a manufacturing line. I know some FANUC robots are going to go along the line. I want to show what those are going to look like. I'm not actually picking the robot I'm going to use. Let me just grab a robot arm, and I'll put it on as a sort of prop. A third example is models to learn from. So we have a lot of models in our community that are there because they illustrate a really elegant point. So people actually use them as part of the Q&A process. People post a question, someone else will answer it, and illustrate the example with specific CAD models. And here's an example of probably one of the most complex planetary gear sets I've ever seen. And this is part of a Q&A series of answers that was really amazing to see how it developed. So 3 examples of crowdsourcing, of ways you can reuse models. And I think that the general theme here is don't redesign things, especially in the concept phase when you want to go fast, iterate, go find parts to reuse. So now we've got our concept. We now move into detailed design. And this is, I'm going to spend a little bit of time here because this is where people really get bogged down a lot. So you need to collaborate. Very few models, very few things are now built with one person. And there are now tools. You're seeing the theme here. We do one of these things. We don't do all of them. There are various tools now that make it easier for you to collaborate with folks both inside and outside your discipline. So let me give an example where this is useful. This is a razor. A lot of us own a razor. Not all of us, a lot of us own a razor. I actually worked at a razor company briefly. So I can tell you from personal experience, there are a lot of people involved in the design of something as simple as a razor. There's marketing who has ideas about how it needs to fit in with the brand image they're projecting. There's the analysis going through a CAD operator where you're actually doing design of the parts where you want to make sure they don't fail or they don't break. There's industrial designers involved because you want it to look really cool. And then when you actually get to the part of making it, you go through a mold design. A lot of it is injection molded. It goes through a mold design to a manufacturing engineering step, and finally on to manufacturing. So these are all the people involved in a fairly simple product. In blue, you see all the different tools these people are using. So SolidWorks does a lot of the mechanical work. MoldFlow is a package that helps you figure out how it's going to work when you actually want to injection mold something. Marketing, we use mostly just pictures. We like pretty pictures. Rhino or StudioMax are two different packages that industrial designers use. A lot of the mold shops, your mold shop may not use the same CAD program you use. Maybe they use NX. And then obviously you can do tool path generation when you actually move to manufacturing. So a really simple product, an enormous number of people that need to coordinate and communicate throughout that design process. And when you look at how this is done today, it's actually pretty painful. So people are moving files around, they're trying to manage the CAD files, they're using Dropbox, e-drawings. Many of you, especially in startups, are probably doing some of these things. Many of you probably are using this old-fashioned model while you're trying to move things around, but we hear a lot of Dropbox. Who here is using Dropbox to manage CAD? There you go. Probably one of the world's most popular PDM systems. Terrible for PDM. So these are all tools people are using. They don't work very well. So now I'm going to get grossly commercial on you for a second. I'm actually going to show you a brief video of GrabCAD Workbench. I didn't want to. It's a web-based product, it's a cloud product. I didn't want to try to risk the internet. So I'm going to show a very brief video here. If I can click on it. So we built a platform for sharing and managing CAD files that is easy to use. It's cloud-based. It has a desktop app that allows you to synchronize the project in the cloud with the files on your desktop, because CAD systems, for the most part, want to be close to the files they're operating on. So you come in the morning, it's blue that tells you that someone else has checked in new files. You click Update, brings the files down. This is the web-based tool. So this is our project update feed, sort of like Facebook for CAD. You can dive into the actual models themselves. We support CAD generic, so we support all CAD systems. You can lock and unlock. This allows you to make sure that you and someone else aren't editing the same model at the same time. If I go into the model and make an edit to it, so this is in SolidWorks now, I'm changing the spindle on that CNC machine. There's a second configuration. Back to the desktop. I can see I have made a change. I'm going to upload it, push it back to the cloud so my coworkers know that I've checked in a new version. It's very similar to GitHub or SVN, if anybody of you are software folks. It uploads the model. I go back to the model in the viewer. You can see that I've made the update, shows the update that I made in the feed. If I click on it, it launches the viewer. This is great for non-CAD users. So some of the folks in that loop were not actually CAD users. And we can see all the version history. So it tracks all the versions I've made. And in fact, I can actually compare the versions visually, which I don't think we're going to do here. It's got a full bill of materials. You can scroll through it and see different components, turn them on and off. You can explode it to see what's going on inside. That's my personal favorite. You can section view, see what's going on inside in a different way on any different plane. You can measure, we can do point-to-point measurement, plane-to-plane. So a lot of sort of CAD, we don't do CAD often, we're not a CAD system, but we allow you to interrogate models in a variety of ways. Again, think about this as for someone who may be a mold maker who's not a CAD user, doesn't have your CAD system. This gives them a chance to actually give you feedback on the design without having to buy a $10,000 seat of SolidWorks and learn how to use it. So this is actually a neat feature. It's a version comparison tool, and now we're showing you commenting. So this version comparison allows me to see visually what changed in the model. It highlights it in colors, and then I can draw on the model and make comments. And these comments show up in the feed for other collaborators. So it allows other people in the project to see what I did, or allows me to comment on what they did. So compare this to Dropbox, where you end up making a change, Dropbox syncs it sort of in the background, you don't really know, and then you're sending emails back and forth trying to explain what happened. We can mark as revisions. So versioning is automatic. Every time you check it in, it's a version. Occasionally you want to mark something as a revision. So this is revision A. I made a comment there to tell somebody why revision A is significant. Maybe this is the one we're going to release to manufacturing. Here's the revision. And then we're back to the CAD viewer, sorry, the file viewer. It's a little smoother when I do this face-to-face, but the video works. Partner spaces. So when you get to the part of you releasing to a partner, like a manufacturer, you may not want that person to see all the versions and all the comments. We can create a special folder, just invite them to that folder, and they only have permissions in that specific component that you publish to that folder. So think of it as a very simplified release process. I'm going to release this version to this person. No one else can see it. And this is just adding people as simple as typing their email in. So it's all web-based. They're going to get a link. They click on the link. It takes them back to Workbench, and they can see the configuration you've selected for them to see. There's the viewer again. As we go back to the feed, it shows you now I've added a partner, I made this update, I made that revision, so you can see all the changes that have been made showing up in this feed. Again, great for people that are working together, may not be co-located, maybe it's a distributed team. So, that was my somewhat hurried tour of Workbench. Any questions before I move on?
Do all parties buy into this, or is there an owner, your GrabCAD license?
So how do we license?
People did look at it or something?
Yeah, so we not everyone has to buy a license. So basically we have different levels of ownership, and certain people have to pay for a seat, and certain people don't. So for example, partners, I showed you a partner space. If I want to invite a partner into a partner space, they don't need to buy a seat. But anybody who's going to be using the desktop sync tool, for example, has to buy a seat.
Is this password protected?
Yes.
Nowhere down the street you can't just do all the CAD?
Yes. So yes, that's a great question. So I should make it clear that the community and some of the tools, I've shown you a bunch of different things we do. Workbench is completely separate. It's highly secure. The only people that can see a project are people you invite specifically, and it is password. So if you invite someone as a collaborator, for example, they'll get an email that says, Rob has invited you to this project, click here. The first step they get is create a password so we can verify you when you come back. We do give you the option for partner spaces to make them password open. In other words, just publish the link, but most people use the password option. Any other questions?
Are your models, your library of models, available to people outside of the engineering business?
Yes, so anybody can sign up. They are CAD models though, so we find that people generally don't sign up unless they're CAD users. They don't do you much good if you're not a CAD
Would it
user.
do any good in a 3D modeling program?
Most will draw, well, you can bring them in. As long as you can import, for example, an IGES file or a step file, which may like an STL, most of them can. The different files will show different, they have different types. So it's whatever the member uploaded is what's there. So if people upload an STL, you can download an STL. That's great for 3D printing. If they upload a SolidWorks file, you can download a SolidWorks file. Okay. Sorry, go ahead.
Is there any, can you license your file, or say I make a useful CAD part that I want to sell that someone might pay like $1 or something?
Yeah.
Is there any model around that?
Not for us. There are places to do that. We don't do that. Our library is explicitly non-commercial use. So people do contact us periodically and ask, hey, I'd like to use that model for this commercial purpose. And our answer is great. It's a community. Every model has a name of the guy or the person who made it up in the corner. Click on that, send them a message. And we have lots of examples of people using models commercially. In those cases, there may be money involved. Recently, one of the top rendering desktop applications used a model from our community, reached out to the person involved. They found a model they really liked, thought it looked great in an application. They used it with the permission of the author, and now that author gets around and go and point out the box on people's desk has his model line. So we have a bunch of examples like that.
So the guy in India got no money for what he did for GE?
Oh, I'm sorry. Like I said, there's actually multiple different things.
Okay.
So for challenges, this is the confusing part of GrabCAD. It's all about open engineering. We do a bunch of different things. So the community is completely free. Challenges actually are rewards. So the guy in India actually got $10,000, I think. So, and it's published up front. So on the challenges page I showed you, there's a list of awards. And typically there's awards for up to 20 finalists. They each get maybe $1,000. And then 10 or 5 winners, they get more. And in that case, I think it was $10,000 for first place. So those monetary awards for the challenges. Great, okay. Let me touch on the last 2 steps in this process. So now we're past the design process, we're into analysis and prototyping. This is one that's changed a lot. We were actually having a discussion earlier about some of these. There's Shapeways, I can't remember who I was talking to, but we were talking about Shapeways as a great way to prototype. So in the old days, you had to hire someone. There were companies that would mold things out of clay for you. They probably still exist. They probably don't have as much business as they used to. It's gotten much faster to prototype. We're working with a company in Boston that's making a onesie for babies with a monitor attached to it, and respiration, heartbeat, things like that. So giving parents a little more information on what their baby's doing. And actually, we interviewed them for the book, and they talked about the fact that they went through 100 prototypes in a year. And prototyping was critical for them because this is a device you're going to put on your baby. And it turns out, as a parent, I can tell you, I'm a little sensitive about things that I attach to my child. So being actually prototype it, high fidelity prototype, and show it to a parent was a huge value to them. And they went through 100 prototypes in a year, which is crazy compared to how they used to do it. And they used, they had a 3D printer. I think they worked with Protomold. They didn't use the 2, I don't think, other than 3. But these are all different tools. So Shapeways is a 3D printing marketplace. So back to your question about buying things, Shapeways actually allows you to buy, to do 3D printing. You can be a host, you can put models up there and people can buy them. And Shapeways actually 3D prints them and mails them to you. SparkFun is great for prototyping electronics. Anybody here use SparkFun? They're pretty, yep, there you go. They're pretty useful. The others exist, everyone probably recognizes the MakerBot here. We've got a couple of these in our office. Great for prototyping components, or just making random stuff, that's what we do. Protomold, sounds like it is what it sounds like. They'll do rapid prototyping of molds. And I made this slide a year ago. I honestly, has anybody used Pinocchio? I don't know what Pinocchio does. What does Pinocchio do?
They do 3D printing, but they also do laser cutting.
So that's a fabrication. They do fabrication of various sorts, yeah. If anybody's here from Pinocchio, I apologize. Sorry, don't remember. So prototyping's got a lot faster. Again, when I compare this to 10 or 15 years ago, where you actually had to cut things or make things or carve them, it's gotten enormously faster. So now you can build it quickly, see what it looks like. Final step in the process, manufacture. I won't say too much about this, except to say there are a lot more options than there used to be. So these are all examples of online either marketplaces or brokers that will either sell you a component or connect you with a custom manufacturer. Alibaba, I think now is the largest e-commerce company in the world. It's shocking how fast they've grown. You can buy anything on Alibaba. Fabricating.com and NFG are both similar. They'll connect you with a custom fabricator, sheet metal, plastics, things like that. Much easier than the old day of calling people up by the yellow pages, trying to find someone to make your thing. And most importantly, you don't need to own your own factory anymore. So that's my whirlwind tour. You might say, well, we're all set then, right? We're in the beautiful, beautiful land. And the answer is not really. So some of you probably had questions along the way. There's concerns on intellectual property. When we say open to people, they sort of flinch a little bit. They're worried about, how do I protect my intellectual property? How do I know it's secure? How do I know it's clear who the ownership is of property, especially with crowdsourcing? Security, whenever you talk about using the internet to do anything business-oriented, you have to answer questions about security. We still run the incompatible systems and file formats. A SolidWorks file, a SolidWorks 2013 file cannot be opened by a SolidWorks 2012 user. So you're into problems with that when you're sharing. The communication tools, as I mentioned, are cumbersome or expensive. And there's still these cultural barriers. So we can't solve all these, but we certainly believe we can do better. And we're hoping to help make that happen. So that's my brief whirlwind tour of open engineering. As I said, I'll just recap our business because I realized it was a little bit confusing. So we have the free community and we offer Workbench. We basically make money off Workbench. That's the business we're in. We sell Workbench. We sell a lot of them to startups, which is one of the reasons I'm out talking to startups. A lot of the folks in our community are startups. We have a number of startup organizations that have started in the community. People found each other through our community. And then we offer Workbench as people start to form the team and need to collaborate and keep track of who's working on what. A lot of hardware startups use our Workbench product to do that. So that's GrabCAD. Thank you for your time. I really appreciate it. Any other questions?
So why don't you try to tackle the CAD interoperability problem, maybe like some kind of middleware that can solve that, SolidWorks 2012 to 2013, the Autodesk, is a really big problem.
It's a really big problem. So it turns out it's a math problem,
really?
Believe it or not. So the root of it is, oh God, anyone know what a kernel is? I'm going to give a very brief, yeah, there you go. It's the same group of folks. So different CAD systems use different set of mathematical assumptions to build stuff. And once you've made that set of assumptions, it's really hard to move them. So we do offer some tools. So we offer a neutral file translator. So if you upload a SolidWorks model to Workbench, anyone else can download it, your partners can download it as a neutral format, and there's 5 or 6 common neutral formats. But when you move from a proprietary format to a neutral format, you lose a lot of information. SolidWorks embeds what we call design intent, the process by which you got to the final product. That's all embedded in that object, but it's embedded in a series of proprietary ways. And Autodesk, for example, Inventor, uses different assumptions. So there are translators that can move back and forth. It's very hard to move back and forth with high fidelity. So we do some of it. We actually, the viewer we use uses some of that technology. We're able to view any CAD system, and that's actually a non-trivial exercise. But being able to actually, you upload as SolidWorks and download as Inventor is even a harder exercise. Any other questions? I could talk about CAD all night.
What does a seat cost?
Oh, sorry, yeah, that's a great question. What does the seat cost? $59 a month. It's cheap.
So in the caster example, say I was building a robot and the intelligence or whatever in the robot is the secret sauce and the caster doesn't matter. So I can't download the caster CAD file and use that for a commercially sellable robot?
No, so no. The quick answer is no. They're for non-commercial use. So casters are a tough example because you would never make a caster anyway. You would just buy one. Yeah. So people do ask questions like, can I download this and fabricate it and then sell it? That's sort of the more commercial model. And the answer to that is explicitly no. That people are uploading it for non-commercial use. And whenever it's a question, well, is this commercial use? Our answer is always ask the person who made it. Right? It's a community. Just ask them. And people are generally thrilled to work with each other. So in general, people are very open. And as I said, there are people who are making deals, but it's a point we're not brokering those deals. We're just introducing people to each other. Sorry, to answer the question. Yes, sir.
So if you got 3 CAD guys and half a dozen people looking at it, what do you need? 1 seat, 2 seats, 3 seats?
3 CAD guys and half dozen people looking at it. You probably need 3 seats.
So it's tied to CAD people then?
Yeah, it's primarily CAD to CAD. So we actually have a free version, so I'll answer in more detail. So we actually have multiple pricing plans, and so there's a free level. And so what most people do, so the thing is free is good for non-CAD users who will just be viewing and not viewing very often. So one of the restrictions on it is you can only have 2 projects. Then there's the $59 seat that gives you unlimited projects as well as a series of file management tools. So there we have sort of the sharing piece that's just largely free with some limitations. And then we have essentially, which is a PDM tool, product data management tool. And that has the file syncing, locking, version control, basically all the things you'd expect from a mature product data management solution. And that's what we charge for. So again, there's 2 different ways to get to free. One is this free tier pricing, limited to 2 projects, and the other is partners. If you're just invited to a partner space, you don't have access to some of the features, and it's a free seat. So in general, people, if you've got 5 engineers on the team, you'll end up buying 5 seats for the 5 engineers. They'll use Workbench as the way of making sure they're not getting in each other's way or working on the wrong file version. We have endless stories of people talking about, yeah, I opened up the file, I worked on it all morning, and then I discovered that Bob had saved another version and hadn't uploaded to the network drive yet, right? The Workbench largely eliminates that problem by making sure everybody always knows what the status is and by allowing you to lock. It also allows you to roll back, so it acts as a backup system. But the viewing is largely free.
What happens if you're a small company, you use it for a little while, and then you're off doing something else, and maybe you're not paying your $59 a month?
Yeah.
What happens to your system, your data?
Well, you get a phone call from me, first of all. You're not paying $59 a month. So nothing bad happens is the quick answer. We recognize that we're holding the crown jewels for most people. So first of all, it's largely, most people, if you're paying for it, you're getting the desktop sync. So most people are actually syncing the files to the desktop. So we use Amazon as our cloud service provider. So it's very secure. It's redundancy, lots of it. But let's assume that Virginia blew up. The entire state of Virginia blew up. That would destroy us. So I'd have other problems. But you'd be worried about your CAD models. And in your case, you largely have them synchronized to your desktop anyway. And we will not just turn you off. So you're never going to lose access to them all of a sudden. And again, because they're largely synchronized, it's a low-risk situation. We also have some folks that are actually synchronizing. You can set up the desktop application on a server and synchronize all of everybody's projects to the server. You have to buy another seat for this. But synchronize all of everybody's projects to the server, and then you have a copy of everything. That's for the truly paranoid. We have a few of those. Yes?
Any chance of y'all extending into the electrical CAD area?
Yes, so we have a little bit, but not very much. So mechanical CAD has its own set of challenges. Once we get done with those, we'll do electrical, but not probably very soon. We do get questions a lot about, mostly about the mechanical properties of electrical components. So that comes up a lot. People do use this for electromechanical design, but we don't do any of the like circuit design or circuit layout or PCB layout, things like that. Any other questions? Workbench, the community, challenges, my favorite CAD system.
Flip back to your Outlook page with Alabama.
Sure. And there are more now, I should add. These are the 3, again, the slides, I wrote the slides about 6 months ago. These are three that I knew about, but it's getting easier and easier to find options for manufacturing. Great. Well, if you have any other questions, I'm Rob Stevens. I'm Rob at GrabCAD. You can find me online on Twitter, all the various places, and I'll be here this evening if you have other questions you want to talk about. Thank you very much. It was great to talk to you.
Justin Jensen. All right. So we're gonna have Justin Jensen of Synetics come up, and I'll bring up his Kickstarter page here so we know what he's talking about, and he'll have 10 minutes, or actually we got more time, so you can take 10, 15, whatever to do that.
We just can't play video on here.
Yeah.
I have it on like a card. Does
this one work?
Yeah. Audio works.
Hey guys, how's it going? Justin. Hello. Hey. Yeah, so I'm Justin Jensen. I founded a company here in Austin called Synetics about 3 years ago-ish, 2.5 years ago or something. It started with the first product that was a small little camera dolly, a set of wheels that attach on a little tripod, and we launched that on Kickstarter. And that was 2 years ago when Kickstarter was just getting started, so we figured we'd give it a try, and it was a really cool experience to put the product up and get a lot of feedback from a lot of people and get their ideas of other things that they wanted us to do. So that's kind of what fueled our initial growth and kind of how we went into building other products and whatnot. So our company's story is really, at its core, the most interesting thing about it is that we put up a project and this community kind of came together trying to solve a similar problem, which the initial problem was that I was working as a filmmaker and had to carry really bulky gear around to stabilize my camera. So I wanted to be able to shoot really high quality video and not have a huge set of tools with me so that I could film it, So I wanted to be able to be a one-man show and show up and film an event and make something that looked like it was a really high production value. So it's been this core mission of building filmmaking equipment that fits in someone's backpack that they can pull out and use easily, and that's kind of where we've been going. And so this is actually our third Kickstarter project over the last couple of years, and I'll show you the video here in a second and take some questions after that and not take up too much time. But yeah, it's basically a modular motor control system for cameras. It breaks down into several different elements. I brought one with me. I'm not going to show you a lot from this distance, but if anyone wants to come out and check it out, it's just a really simple motor that makes it a lot of different moves. It has a really smart controller that we've worked on the software for years, trying to make it do some really cool stuff. It's really good for time-lapse photography and video and making repeatable moves and being really precise. So that's not near as cool as the video. One thing about Kickstarter projects in general and selling a product online, I think one of the main reasons that I got into video and into building video equipment is that video is a really, really good way to tell your story. I can stand up here and talk in front of you guys and look like an idiot, you know, but if I play a video, I can have it ready to go ahead of time and get you a lot more information in a short amount of time. So I'm gonna go ahead and play this guy and then just take some questions after that.
Video is a powerful way to tell your story. But creating captivating cinematic footage is difficult. The biggest difference between amateur video and professional film is camera movement. That's why we built a portable, easy to use, and affordable motion control system. Axis 360 is a motorized camera mount that enables you to create dynamic time-lapse photography and video. Its modular design provides precise panning, tilting, and sliding camera moves. And you can combine Axis 360s for 2- and 3-axis motion control. We're excited to offer Axis 360 on Kickstarter and can't wait to see what you create with it. But we need your help to fund the first production. Cinetics began when we launched Cinescapes on Kickstarter. Hackers' feedback poured in. So we got to work designing, building, and testing. Axis 360 is a result of the features and functions that you requested. We're beyond grateful to the Kickstarter community for giving us the opportunity to build Axis 360. Please support us by becoming a backer and sharing our project, so that we can continue to build technology to help you put your cinematic ideas in motion.
Thanks, guys. That was a little painful to listen to.
Great bass response there.
I'm glad we're not selling audio equipment. No, all good. Yeah, so that's the story. It's fun building this kind of gear, and Austin's a great place to do it. And coming to events like this is good for us. If anyone's interested in what we're doing, definitely reach out. Give me a shout. Our website is cinetics.com. You can contact us there, and our Kickstarter project is going for 1 more week. So we're busy seeing what we can get it to end up at, and having fun improving the product. One of the really cool things about Kickstarter is that you don't have to deliver the product right away. So if we launch a product in a retail store, you put it there and it's for sale. But in this situation, we put up the project and we listen to what everyone's saying, and we're working during this time before we send the product out to make it even better. So it's a lot of fun to work with the community, and yeah, that's where we're at. So if anyone has any questions, I'm happy to answer them. And if not, then give me a shout.
I can't quite read this. Does it say $75,000 goal?
Yeah, that's right. We should have said that at 1.
What are you gonna do with all that extra money?
Well, it's not extra money. People are pre-ordering the product, right? So basically it's causing us to be in a giant hole right now, pre-ordering parts. But no, it's all good. Yeah, it's and like I was saying before, as we raise more and more money, we've been setting like higher goals. So if we get to For example, if we get to $700,000, we have $700,000. We have a software update laid out where we're just keeping adding to the product. So kind of trying to encourage people to keep sharing the project and keep it moving forward, and at the same time trying to make it as cool as we can.
What type of speeds can the modem have?
Yeah, so it's a good question. It's one of the most common ones we get. So it's definitely built to move really slowly. For video moves, we're mostly concerned about how precise the move is, and doing a really dramatic. If I'm filming this room and do something very, very incrementally slow, or very, very slow, then it's a noticeable effect. So if it's spinning, like doing a pan, the thing will do 3 different moves. It'll pan, doing a rotation this way, or it'll tilt, rotating up, or it'll mount on the slider. Here's a little graphic that shows that a lot better than me talking. Yeah, so it's kind of the biggest benefit of the system is how modular it is and how it can fit into different situations. So when it can rotate pretty fast, but on the slider it moves pretty slow, something like 2.5 centimeters a second. So it's pretty slow. But the other side of that is it can go really, really, really slow, making like a tiny, minute movement every set amount of time. So I can move like 1/100 of a millimeter every hour if I want, and shoot something like really crazy slow.
Where are you manufacturing this?
In Austin, Texas. No, that's true. We get parts from all over the world. Depending on what part it is, we get circuit boards from China, bearings from California, whatever, you know, and all the parts are shipped here, and we do all the final assembly and build everything out here.
How do you identify those sources? Which one you're gonna purchase from?
How do we? Oh, okay, all right. Like finding the right supplier.
Yeah.
Yeah, that's a good question. I guess for us, it's been a lot. Initially, finding them I think the most important thing was talking to other companies doing similar things and getting recommendations. Our best supplier came from a recommendation from a friend. So that's really big. And we also used sites like Rob had shown, like MFG.com and Alibaba. We use stuff like that. And at the end of the day, we get suppliers from all these different places, and the ones we end up sticking with are the ones that do a good job, right? But yeah, from all over the place, I guess is a bad answer.
How many have you fired percentage-wise?
Fired? Not ordered from again? Yeah, I don't know. I could make up a number, but I'm not sure. Most of them will work out all right if we do our due diligence and hire the right people.
What's your #1 suggestion for a successful Kickstarter?
Ooh, one suggestion. Number 1 would be you get out of it what you put into it. I couldn't even guess how many hours we put into getting the video right, getting the entire presentation right. Like, so me being, I'm a mechanical engineer, and so I want to build this awesome product. And it takes my team to slap me around and say, hold on, we need to present it well, and spend a lot of our effort on the presentation. So telling the story in the video and just having everything looked over 100 times. In Kickstarter in particular, they give you a link that you can share with people, so that before you launch your project, you can take your link and send it to whoever you want. And that's hugely helpful for us to send it to whoever they are, like our team's old college professors, or just people that aren't directly connected to the project. So I think that would be my big answer, my #1 thing, if that helps.
I would like you to talk a little more about that. You're talking about we and us and our team and doing this thing that you've done. Love photography, but yeah, I'd like to hear more about the background of the whole thing for my project. And then I would like to know if you got any video from the Blood Moon. Some of the time lapses on there. Did you get it
right on? I don't have a video, but I have a cool photo.
Okay. And while you're looking for that,
it might take me a minute to find it, but
one thing is when I was looking at your Kickstarter and your project, I went out and did some searching, and I saw some feedback from bloggers. people got a hold of the thing, they were looking at it. Then down below that, of course, there are comments, and some of the comments were positive and some of them were negative. Do you have a team that kind of looks into that, and do you get a hold of those people and get feedback? Like, what are you looking for in that kind of arena right now before you're even in the marketplace?
Yeah, so just to step all the way back and talking about the whole concept of team, right, and working with the right people, and kind of creating a startup, one of the biggest things is hiring a diverse team of different people, right, that are differently skilled than yourselves. And for us, like going into a project like this, there would be no way I would possibly be able to keep up with things if I'm doing this by myself. And like if you're looking at the comments and everything in there, our project is nothing compared to some. You know, it's still a lot of work to keep up with what everyone's saying and across so many platforms and everything. So it's definitely really important for us to collaborate with our entire team and to get everyone's opinion and wrap that together. And then as far as the comments and working with the backers of the project, a Kickstarter backer is amazingly more vocal than your regular customer, right? So like going back to the example of selling in retail, right? They're just gonna be upset with the product and not know their answer or send a complaint or whatever. So it's really nice in this situation where if somebody has a gripe, they're saying it like a month before they get their product, you know, and so we can work it out with them. But really in general, I think that it's been really, really positive. There are people that your handful of people that are negative, but you can't really let it bother you and do your best to answer their question. And a lot of them are really interested in, okay, I'm going to get this, and then like what next component do I want so that it'll do what I want, like, to fix their situation. I don't know if I'm making sense, but it's kind of what.
Well, I mean, I'm not just specifically talking about the Kickstarter comments. I'm talking about comments on the web.
Oh, right.
Like there's bloggers out there that got your product and looked at your product.
Yeah, and to talk a little bit about that, I think that's really important for any product launch to have the product in the hands of press, or to at least have them have the information that they need so that they can write about it while it's interesting, while it's new. And so for example, like we sent our product to a website called DP Review, which is like a photo video website. And he had some issues when he reviewed it. Like he wrote his whole piece, and at the bottom he's like, this is awesome, this is awesome, this is awesome, but this is ridiculous. So we were able to look at that and be like, okay, well that's easy to fix. We can change that before we send anything out. So just the being able to plan ahead and have the product finished enough that you can send it out to press ahead of time is definitely helpful to make sure that your product is refined as possible. No matter how many prototypes we went through getting it to that point, like still sending it out to experienced people and getting their opinion has been really valuable to us. And just how we don't even know yet, but it's going to be very helpful, like being able to improve it that little bit much more before we actually send the product out. At least a little bit helpful for peace of mind.
Thank you.
Of course.
Can you talk about financial challenges of running a Kickstarter, or getting off where you started off, getting off the ground, and how we're already planning on a startup that's self-financing, and then Kickstarter, it could cause its own financing challenges, right? I mean, if you've got a lot of inventory to buy and you're offering something at a lower margin because it's pre-finished.
Totally. Yeah, that's a really good question, and definitely something that I think about all the time, right? So we did our first project like I said, 2.5 years ago, and luckily it was a much less capital intensive project. You know, we built like 2 molds or something. So that one was, to some degree, we got really lucky that product didn't cost much to make and it did really well. And so that kind of fueled our growth into these next products. And we've tried to have a good cash flow or more, I should say, manage our spend much better, so that we were able to have money to invest into this project ahead of time. Which this one was definitely a much more substantial investment to build all the tools, just because there's so many more. But yeah, it's this project would be impossible for us to just come off the with zero money, you know, and make it happen. So like one thing about this project is we had built all of our tools. We already have them all built, you know, so that we can offer we were talking about this earlier, like so that we can ship our products in a reasonable amount of time. So that when people go to our page right now and they look at it like, oh my God, this is cool, I want to back it, and we want to be able to offer a shipment date in May, or some of them were shipping in April. And so to do that, we had to finance the tools and all the inventory ahead of time. And so that's definitely been tough. And we're as broke as we've ever been right now, you know. So, so yeah, we're ready for that check to get here, get us out of the red. But yeah, I don't know if I can answer it.
Well, I mean, part of it is, you know, people look at Kickstarter and say, oh my gosh, you know, you only asked for 75 and you got $500,000. You must be rolling in money. But that's not necessarily the, I mean, there's a potential for profit if everything comes through. But.
Yeah, and that's also talking a little bit about the goal that you set. Like Kickstarter works that if you set a goal and you don't reach it, you don't get any of it. So our $75,000 goal is not $75,000 and we're like eating cake and drinking champagne. You know, that's like, well, we know we're gonna get to that, so like we won't give away things if we don't get there. You know, so that's kind of a unique thing in itself. But I don't know if that.
How are your sales doing outside of Kickstarter?
Yeah, so we have several different products, and they all do are doing differently based on kind of their launch date. They have different life cycles of how they do. Like our Cinescates product, it still sells and does all right, like, but it's not like driving the company for us or anything. We have another motor control product that's kind of our keeping us afloat while we get this one out the door, and this one isn't selling. We'll go on retail sales as soon as this project is over, so a week and a half or something. So that'll be good too. But
are you talking with any? Sorry, are you talking with any of the retailers? I mean, is this going to be in stores anytime soon?
Yeah, so it's the project will end next Friday, and it will be available to pre-order on, like, for example, B&H Photography the next Monday. But yeah, we have a small handful of retailers that we work with. We've tried several different things and tried to reach out to different things, but really for us, it's a niche product and it sells really well when people see the video. And for whatever other reasons, we seem to do the best online and through photo specialty stores, or the bigger photo specialty stores. So yeah, it's kind of like Kickstarter and our website are our core business, and like get our biggest, it's where we sell the most product, but through the retailers, that's like kind of what helps us to finance this and to get here, like having their much more regular sales than ours. It's definitely helpful to balance things out.
How did you find all your team members?
That's a good question. So they're from all over the place. One I married.
Cheap labor.
No, and then other ones just listing resumes, like through whatever Indeed.com and through the UT listings and whatever we've done. I think each person has kind of come from a different things, and we're only 6 people in our company, and then a couple of them have come from recommendations from other employees. So,
Do you find a common trade between them?
between the employees,
Yeah, well, I mean,
they all deal with me. So.
Probably photography.
Yeah, they have to have definitely when we're talking to people about joining the team, like you have to have like some interest in photo, video, and like what we're actually building, right? No matter whether you're building the product or not, like if you're going to do it day in and day out, similar to any other job, right? Our team is all pretty young. I think you have to be, or you don't have to be at all, but like it's easier to get the right group of people that are willing to kind of jump in and give it a go. So that's kind of how we've been.
So were you a filmmaker who then became a mechanical engineering student, or a student who became a filmmaker?
Yeah, I don't know. No, I've always been into cameras and studied mechanical engineering. Then I went and worked for Accenture doing IT consulting and was doing moonlighting as a filmmaker and photographer. So I've always that was always my passion. I went to graduate school and studied entrepreneurship. And when I was there, that's my focus was kind of in studying imaging and what kind of product, or I was looking to do a startup in that space. So it took me a long time to get there, but
you're an old guy.
You know. No, that's the story.
Is that it? Or we got one more
I
question, I
already
guess.
gave him one.
How do you handle IP protection before you launch? Patents?
Yeah, so before we launched our very first product, filed a provisional patent. It was so basically to not spend the whole amount on a real utility patent, and then when it did well, filed the utility or several utility patents. And so we have 3 patents that cover kind of core technology that spreads across our products. Cool. Thanks, guys.
Super mechanical. I see all back there. And Justin's being bashful. He didn't just go to grad school. He went to the MIT Media Lab. And common thread here, I guess John went to the MIT Media Lab too.
Did y'all know each other at the MIT Media Lab?
We've only known each other since Austin, so we've gotten to hang out a bit here.
Yep. Yeah, we were in slightly different years, right? I think we were off a year or two.
Yeah, right. That's 2011.
Right, so anyway, David is our model and demonstrator anyway. So last time I talked here, we were just about to launch our new Kickstarter, which was for range. And let's see, how did that do? It is a cooking thermometer for the iPhone. Wow. I'm insulted.
Your Kickstarter.
I guess I shouldn't name it things like range. You know? Like a challenge. Hey, we got the first hit on Google for Twine, so. Right, so we did okay here, and the main thing I wanted to talk about, actually, let's see if I can put this guys here, was some of the interesting things we did in the slog to actually make this thing. So it's one thing to design a product and even design it for what you think is manufacturing, but then to actually go through that process, it's interesting. So, you know, for example, Rob was talking about your Alibabas and photomolds and shapeways and things like that, but there's kind of an in-between spot where you do well enough that you don't want to make this thing by hand, or you can't. But I mean, maybe I'm talking specifically about Kickstarters, but it could really be for anything. But you don't really have the volume to go to China. And there's a lot of risk involved in going to China, going to Alibaba. We have sourced a few parts, but a lot of labor, this guy knows, goes into simply vetting your suppliers, making sure they get you exactly what you want, so much back and forth. And a lot of these things are, you know, hardware is hard, as they say, but making in the US is somewhat less hard. So, you know, we're pretty risk averse. We like to be very careful about these things, and being able to talk directly and to just wear out manufacturing engineers with questions and get it just the way we want is important to us. So well, let's see, what I gotta go through here. Oh yeah, so anyway, you know, Range is a cooking, brewing, grilling thermometer. It's made out of silicone and stainless steel. It, you know, uses a clever little communications method. Basically has a microprocessor that is being a modem and talking to your iOS device over the headphone jack. And it powers it as well. And it comes with a nice little app, and it comes with an SDK that David wrote, and This makes it easy enough to make an app that reads the temperature from the world around you by making a web page. So you can just make it looks kind of like a web app, but it is a native app. You can do this yourself. We can give you the SDK if you want one. And so we had to make the thing out of silicone because we were going for something premium, something that felt right next to an Apple device. And so color and design and the feel were all really important. Never done silicone before. Silicone is not a thing that you can do at Protomold. So our previous product, Twine, we used Protomold, and that was a really nice fit, especially because they have an online tool where you upload a CAD file and they tell you what's wrong with it and what you need to fix to get it made, which is a lot better for everyone than talking to mold engineers and then to the point where they stop returning their calls. Did that a few times. Hey, I want to learn about the process so I know how to design things better. So Protomold is nice, but they don't do silicone. And in fact, with Twine, we tried using Santoprene. That was the closest kind of thing they do, and they're not experienced enough with it. So we had some problems. We had to go back and forth. Some near heart attacks with $15,000 mold changes. Luckily, they made a mistake too. So this time we had to kind of up our game a bit and actually find a quote-unquote real manufacturer. And to get this done, again, you're spending lots of money on tools, and it's a really scary thing to go to China and do it. And I see a lot of Kickstarters who do well, but not like millions and millions, who think that, oh, the next step is to go to China. And maybe it is. I wouldn't know because I haven't done that. But it actually involves going to China, standing over people's shoulders, and then being surprised when you go home and then your parts come anyway and there's still mistakes. It's just going to happen. So when you can work in a tighter iteration loop with your manufacturer, that's really nice. And here's some sketches, a lot of testing. And here's our manufacturer in Maine. And I went up there, and it was a lot cheaper and quicker flight to go to Maine and get things done than to go to China. And it was great because I went to Maine thinking like, okay, my first sample parts are going to be the ones that we can ship to our first run backers, people who got the first few hundred. We get to hit a milestone before Christmas. Feels good. And of course, they made just one critical mistake, which I couldn't find a picture of, probably because I was just so angry I didn't keep any. If you notice on, let's see. So on the handle here, there's a little range logo. And it's an avant-garde ITC. It's a particular font. I'm a designer. And that's our branding, right? And they got the word right, but they didn't really have a concept of font. They were font blind. So someone did somewhere down the line in the tooling, not the guys who do the injection molding for us, not even the guys who do the tooling, but the guys who they sent out to do laser engraving of fine details on that tooling, someone had decided, okay, it just needs to say range. And it seems weird because it would take more work to actually wipe it off our CAD file and then to go back, but it must have just saved them that much time, machine time, that they thought it was worth it. So, that set the whole thing back 2 months. And so, there's some scars, but I think it would probably be worse if I went with a Chinese manufacturer. It's possible. I mean, like Justin was saying, you find suppliers, partners to work with, and you can stick with them. And there's a lot of cost that goes into developing those relationships. And so I think you can find Chinese manufacturers that you can work with who are really good, just like anyone else. But can you afford to go through the cycles and blow through the money to find them the first time? Because we are a little more scared about that. We do that in small parts. And the things that are really important to us, like the aesthetics and getting the case and feel just right, we keep closer to home, especially when it does involve us learning how it's done so we can talk a lot. Then another nice, fun part was actual assembly. So as it ended up, you look at a BOM for a product and you add up all the parts, and then you maybe throw in $1 or $2 for assembly because, whatever. No one sees that, right? So it must not be costing a lot. And I'll blame myself for some of it in that some parts of the manufacturing design is just like, okay, we'll figure out a way to do this later, and we won't. think as much. I mean, it's a shame because I should know better, because with Twine, we designed this thing for assembly. It was great. It took no time. It was like a snap fit thing. It was great. With this, we were going for a higher finish, and that involved like hiding seams and that kind of thing. And so it involved potting silicone with silicone, which means sticking a circuit board into a cavity, putting some silicone that would then take a day to cure, and then you're done with that part. Very, very time consuming, especially to get it the way you want to get it done. And yet we still had it made in dripping springs down the road. That was also very critical, because if we had gotten back thousands of parts that weren't to our specification, well, then we would have just lost all the money that went into the parts and circuit boards and the probes, and also blown a couple of months worth of time, and that would have been just bad. So it was great to have someone nearby. We had a guy who did nothing but do the first run himself, figure out how to do it. He's more anal about the aesthetics than I am, which is awesome. And then he went down to our contract manufacturer and showed them how to do it until they did it to his satisfaction, and now it's scalable. It's nice. Not perfect, but the great thing is down the road if you need to troubleshoot. So, we also take pride in being able to make things as locally as possible, but it also just makes sense for us because we're kind of in this awkward position where we don't just like have the money to scale and do it just like the big guys do. But we can't do it by hand ourselves. So there's kind of this nice middle ground, and there's lots of manufacturers in America. You find this out, and I know, someone earlier had a question of like, well, how do you find your suppliers? And a lot of Googling, really, and then talking to people, and then you learn the questions to ask, and you just build up trust. People have sample parts, all of that. It's just another painful process, but as you learn how to do it, then again, like Rob said about parts, don't repeat what someone else has done or what you've done before. So try to build on what you've learned and live to make the next product. Questions? Yeah.
Can you share who you used in Dripping Springs?
Sure. They're called USTX. They're pretty nice. At least they fit us well.
An assembly house?
Yeah, they do a bunch of different things. They do PCB assembly, and they can do various other things as well.
So the injection molding, locating the local companies, or?
Did not. I think I looked at 3 companies here, and another in-between spot. We haven't tried these types out yet, but there are people who have a Chinese back end and an American front end. And that was a consideration, but just like my spider sense just said, let's not take that additional risk. So out of the 2 we liked, these guys just felt better, gave us a pretty good quote, could make it work. Yeah.
You said silicone on silicone, like potting silicone on silicone. Is that on the temperature end or on the sensor on the?
Yeah. So do you want to also just show it off as we're doing it? So we have a very beautiful iOS 7 app. We made it even before iOS 7 came out, we guessed, right?
So were you talking about like at that end where it plugs in?
Yeah. So all the electronics are in that end. We tried to make it look like a plug, but it's the smart part.
Did you investigate overmolding the electronics?
Won't happen. Yeah, no one would do that because like the temperatures you couldn't. Yeah. At least no one we talked to was comfortable with doing that, but yeah. I mean, like the electronics would have to go in the 250s or so, and liquid silicone rubber is like high 200s.
Right. Okay. And you wanted that part to be in silicone as well.
Yeah. But yeah, so I mean, it has a tiny microprocessor in there that talks to it. Each one has a unique ID, so it remembers that you plugged it in. And one cool thing that we just added in the update is it's kind of got a physical pairing. So if you want to receive remote alerts on another device from that range that David just plugged in, you just plug it into that device, and then it remembers that they were ever connected. And now it's like they have some kind of psychic bond. And through the magic of some cloud stuff that we sweated a lot over, no one has to know about that. There's no typing in accounts or anything like that. You plug it into mine, and his gets like this psychic alert thing when mine hits an alert, hits 300 degrees or whatever.
So you chose to use basically the audio interface and converting the value. Would there be any benefit to using the like an MFI and then the existing?
It's a good question. Well, I mean, I guess being more Apple kosher, you would maybe not run into some little finicky issues that happen. I mean, you know, David spent a lot of time with error correction and making sure this was digital. I mean, this is definitely not the only product I've ever seen that uses a headphone jack, but a lot of them, like there's actually another temperature probe. It's not like oven safe like ours, but it's just like to read ambient temperature. And they use a very simple analog circuit, and as a result, it can be pretty inaccurate depending on a lot of different things. Ours, you know, goes A to D.
It's a digital.
Totally, yeah. And I mean, with the MFI, we're too small to like deal with that. That takes forever. That's, you know, we got to move faster though. Yeah. Any other questions? I mean, most of my answers, by the way, if you ask me the same questions as Justin, I would give you the same answer.
This is a little bit off the wall, but is anybody trying to use this in a microwave oven, and are you prepared for that?
Well, I don't know. I'm not prepared for that, but I don't really know what to do about it. You know? Yeah.
I thought about that, but what I mean,
Yeah.
they're going to do that. What can you do? I mean, in general, we have we are very nice to our customers. We have like a liberal return policy, but I mean, we'll just talk them through it, like try to figure out what happened, and then those people are smart though. Like you'd be surprised. You as an engineer, you're always like designing for absolute worst case things, but you'd be surprised how often the people are not as dumb as you hope. And there's always the ones that are, obviously, but it turns out to not affect like that many people, and so it ends up not being that much of a burden. So
Yeah, and technically, at least, like if you exceed our spec, like this thing, we say everything from the temperature sensor itself to all the materials go to 450, at least the business end. And we spec it a little low. We can go a little higher because you know how people are. But if they do exceed something and they claim like, oh, I don't know what happened, technically, if they want to return it, we can say, well, can we look up what the highest temperature your probe hit, because we can record that. You know, so, you know, aside from the fact that it has all this smart stuff, like, I mean, you know, graphing mode and, you know, all sorts of fancy little intelligent features that take it beyond a normal thermometer. Also, there's just some interesting things you can do that are not necessarily customer focused when you are connecting an object to the internet or even just to a smartphone. Yeah, so anyway. Yeah.
So when we're going wireless?
Next time we talk.
This cost a lot.
Yeah. Yeah.
What's the craziest thing you've seen someone do with it?
Oh God, TBD. We just shipped the first 1,000 last week, so we'll find out. But the craziest thing okay, there are two different people that I thought were interesting. You tell me if you remember any others. One guy said he wanted to melt bismuth crystals with it. Like, I don't even know why, what? And also that was like well over 500 degrees, so we suggested he didn't. And then just another one where we kind of just talked about like, hey, you can, you know, like every post. And we went pretty aggressive in this Kickstarter. We posted every single business day that the Kickstarter was running. And, you know, so we talked a lot about food, and, you know, it wasn't at all about, I mean, the technology or anything like that. People, you know, whatever. People want to get food done with it, or they want to make beer, or, you know, candy, whatever it is. And so, you know, a lot of people throwing out interesting foods that they're making, and, you know, some pretty artisanal stuff. And one guy would just, whenever someone would mention like, oh yeah, I'm gonna make bacon with you, he says, oh yeah, I make this awesome bacon with jalapeno and blah, 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 I'm gonna send you some. Then the next time someone was talking about marshmallows, I make this awesome maple marshmallows, I'm gonna send you some. He never sent us any, so I'm really pissed off. I was hoping we'd get that benefit out of doing like a food-based Kickstarter, but nothing. Yeah.
What does it cost?
It costs. So this is an interesting thing, actually. You know, when I was talking about labor costs, you learn about, God, you can never overprice it, I think. On Kickstarter, $49, and our plan was to retail them for $59, and they are going for $69. And it was pretty interesting because I went to the Chicago House Fair show last month and got a lot of good feedback from people who are not techies at all. It's like $70, not sure, whatever. You know, I mean, just making out of premium materials, and if you look at our website, David also is an amazing photographer, so creates this really good aura around it, where, yeah, it's worth what we pay. And, you know, we also do a great job. I mean, retail is half about packaging, and this is only one of our kinds of packaging, but, you know, did this really cool neat packaging. It was kind of like someone said, it was like the obvious thing to do, but also obviously awesome. You know, so we like to have fun with every part of it. It's a complete product. But all of these things cost money. Like this thing, it's just a meat tray. And it's like, oh, meat trays are cheap. But like the time, you know, you spend a lot of money just on like some custom stickers and a die cut for the cardboard piece inside of it, and then the fulfillment. You know, these things add up. Make sure you get every little thing in there, bomb there.
Whose microprocessor did you use?
Atmos. All right, thank you. One more. Sorry.
What's the response?
So it has a effective rate. If you're using the SDK, it's like 4 hertz, but we actually read out at about 8 hertz, which is, we could read out much faster, but that's just what we go at.
Yeah. And because we're kind of engineering oriented and we hadn't made a food product before, we totally were overkill on like the technical specs. Like this is actually a lot better than most food thermometers. I mean, maybe you don't need that kind of accuracy when you're making meat, but people who do, people who care, it's like, it is cool, it is better. Thanks.